Welcome to the future of mobile development. Kotlin Multiplatform technology has just become stable. Building native mobile applications for both Android and iOS with a shared logic written in Kotlin is just one step away from you. If you are an experienced Kotlin or Android developer and want to explore a cross-platform development, this is the right course for you. This course is adapted for beginners, which is why you will be able to follow along easily. You will learn how to write a shared code for your mobile applications to maximize efficiency and code reuse. You will explore the fundamentals and principles of multi-platform development and gain practical insights into creating a single code base for your mobile projects. Along the way, I'm going to explain a Swift syntax, and you will see how both Swift and Kotlin are very similar to each other. This is a short and concise course, adapted to get you introduced with a topic quickly and efficiently without wasting a minute of your time. It's filled with lots of different information that you are going to need to understand how this technology works behind the scenes. As with all other courses of mine, this one will also include one project that we are going to build while learning this amazing technology. So what are you waiting for? Let's go! You might be wondering what do I need to know to be able to follow this course without a problem? Well, first, you should be already familiar with Kotlin programming language. Then, the basic knowledge of Jetpack Compose is required. And for building an iOS application, you don't need a MacBook, but if you wish to run the application on a simulator, then the macOS is required since you are going to need an Xcode development environment. However, I repeat, that's not mandatory to follow along with this course. And you don't need to know anything about Swift programming language, because if you know Kotlin, Swift will be a piece of cake to you. Other than that, you need an internet connection, a will to learn, and the rest leave it to me, because I'm going to teach you the right stuff in no time. Kotlin Multiplatform, or KMP, is a new technology that simplifies a development process by using the same code for building applications on different platforms like Android, iOS, Windows, Linux, watchOS, and others. That basically means that you will be able to share an application logic between multiple different platforms and only write a platform-specific code when you need to implement a native UI. For example, let's say that you have a product class that is used for serialization and deserialization. And you need to use it in multiple different projects that target different platforms. Without Kotlin Multiplatform, you would have to define that class multiple times, even though its implementation will be the same everywhere. However, with Kotlin Multiplatform, you will be able to define that class only once and reuse it in other different platform-specific modules as well. By sharing your code, you significantly reduce duplication and save time and effort. You can cut costs by maintaining a single codebase for multiple platforms. And, unlike Flutter, Kotlin multi-platform applications are great in performance because they are built natively. The great thing about KMP are multi-platform libraries. To build multi-platform libraries, it's often necessary to have the knowledge of a native development in the respective platforms, like for example Android, iOS, and others, depending on which platform you want to target with your library. This means understanding a specific APIs and frameworks of Android, iOS, and other platforms. The benefit for developers using these multi-platform libraries is that they don't need to know how to implement platform-specific logic on each platform separately. Instead, they write the shared code or the actual implementations once in Kotlin, and the Kotlin Multiplatform tooling takes care of translating this code to the target native platforms like Android and iOS. This ensures that the logic works correctly on both platforms without requiring a developer to write a separate code for each. Now, I will share with you two important resources where you can search to find different multi-platform libraries that are available right now. And of course, with increased popularity of a Kotlin multi-platform technology, there will be more great libraries developed for that purpose as well. The first resource is called libs.kmp.icerock.dev. And on this website, you can also just scroll down below and search for many different kind of multi-platform libraries that are available right now. Also, this list is updating on a regular basis as well. And the second resource is Kotlin Multiplatform Libraries repository on GitHub, where you can also just scroll down below through this README file to find the different categories of multi-platform libraries. And also this repository is being updated on a regular basis, so no worries there. Now, the last thing that I want to mention in this video is about Kotlin multi-platform terminology. So at the end of July in 2023, on the official Kotlin X account, they have announced that Kotlin multi-platform, or a KMP, is the preferred term when referring to the Kotlin multi-platform technology for sharing the code, regardless of the combination of platforms being discussed. So they have basically deprecated the Kotlin Multiplatform Mobile or a KMM product name to resolve the long-standing issue of a naming inconsistency and abbreviation confusion that have puzzled many Kotlin developers over the past years. Which is why now the preferred term is Kotlin Multiplatform or a KMP, while KMM is a deprecated one. Alright, so that will be everything that I wanted to share with you in this video. So if you have any questions, feel free to comment down below, and for this video, that will be all. Before we start coding, first I need to introduce you with a basic Kotlin multi-platform project structure for mobile applications like Android and iOS. Usually, in the root of our project, we are going to see three main directories: Android app, iOS app, and shared. The Android app directory represents an app module and an entry point for our Android application. This directory follows the standard Android application project structure. It contains Android-specific configuration files, then Kotlin files where we define the UI of our Android application, Gradle build file where we declare the Android-specific dependencies and plugins, then a settings Gradle file, Android manifest file, and other well-known Android assets. It uses two Gradle plugins like Kotlin Android and Android application. To access the shared module from our Android application, we declare that shared module as a project dependency. The build configuration of an Android application is located in the Android top-level block of the build script, like we can see right here. On the other hand, an iOS app directory is produced from a Xcode project. Xcode uses its own build system, thus the iOS application project is not connected with other parts of the multi-platform project with a Gradle. Instead, it uses the shared module as an external artifact or the framework. The framework is produced with a Kotlin native compiler, and the framework configuration is stored in the iOS block of the build script within the Kotlin block. It defines the output type framework and the string identifier base name that is used to form the name of the output artifact. Its default value matches the Gradle module name. Additionally, there is a Gradle task with the name of embed and assign Apple framework for Xcode that exposes the framework to the Xcode project the iOS application is built from. The task is built into the multi-platform plugin, and it executes upon each build of the Xcode project to provide the latest version of the framework for the iOS application. Which means we will be able to access a shared module in our iOS application without any issues. In other aspects, the Xcode part of the cross-platform mobile project is a typical iOS application project. And lastly, we have a shared module that contains the core application logic which is used in both Android and iOS targets like classes, functions, and so on. This is a Kotlin Multiplatform module that compiles into an Android library and iOS framework. It uses the Gradle build system with a Kotlin Multiplatform plugin applied and has targets for the Android and iOS. The shared module contains the code that is common for Android and iOS applications. However, to implement the logic on Android and iOS, you sometimes need to write two platform-specific versions of it. To handle such cases, Kotlin offers the expect and actual mechanism, which I'm going to talk about in a separate video. And the source code of the shared module is organized in three different source sets. The first one is a common main, which stores the code that works on both platforms, including the expect declarations. Then we have the Android main, which stores the Android-specific part, including the actual implementations. And we have an iOS main that stores the iOS-specific part, including the actual implementation as well. Now, each source set has its own dependencies, and the Kotlin standard library is automatically added to all source sets so that you don't have to declare it explicitly in your build script. And when you write your own code, you need to add your dependencies in the place that corresponds to the source set. Okay, so that's everything I wanted to share with you in this video. Now you're introduced with a project structure that we are going to use to build a multi-platform project for iOS and Android. And if you have any questions, feel free to comment down below. In the previous video, we have touched a topic about targets and the source sets a little bit, but here I will try to explain them in more details. So Kotlin Multiplatform is a great technology that empowers developers to share code seamlessly across different platforms. Kotlin Multiplatform introduces the concept of a common code that bridges the gap between various platforms. This shared codebase allows developers to write logic once and deploy it across the different environments. For example, let's say that we have a shared directory in which we have defined a common main folder. Whatever we put inside that folder, it will be accessible to all other platforms that we are targeting with our Kotlin Multiplatform project. Even I said whatever you put inside that folder, it doesn't mean that you can add anything, because platform-specific APIs are reserved for other targets or source sets. Those are two concepts that you need to get introduced with: targets and source sets. First, let's start with the targets. So targets define the platform for which the code is compiled. Those platforms could be JVM, JS, Android, iOS, and others. Declaring targets is crucial as it influences the format of produced binaries, available language constructions, and allowed dependencies as well. Targets can help you define where your code will be executed. For example, you might have a target for Android, which means your code will be compiled and run on Android devices. Targets enable you to optimize and adapt your code for the specific requirements and the features of each platform. A Kotlin source set, on the other hand, is a set of source files with its own targets, dependencies, and compiler options. It's the main way to share the code in multi-platform projects. Now, each source set in a multi-platform project contains a set of source files and resources, usually stored in the directory with the name of the source set. Also, each source set specifies a set of targets to which the code in this source set compiles. These targets impact which language constructions and dependencies are available in this source set. And each source set also defines its own dependencies and the compiler options. So Kotlin provides a bunch of predefined source sets, and one of them is Common Main. Common Main is present in all multi-platform projects, and it compiles to all declared targets. For example, a project with a Common Main, iOS main, and JVM main source sets has the following structure. In Gradle scripts, you access source sets by a name inside the Kotlin source sets block. Now, let's talk a little bit about platform-specific source sets. So, other than a common main source set, there can be either a platform-specific or intermediate source sets as well. While having only common code is convenient, it's not always possible. Code in the common main compiles to all declared targets, and Kotlin doesn't allow you to use any platform-specific APIs in there. For example, you cannot use fragments and activities in the common main source set because those APIs are reserved for Android only. As a solution, Kotlin creates platform-specific source sets, and each target has a corresponding platform source set that compiles for only that target. For example, a JVM target has the corresponding JVM main source set that compiles only to JVM. Android target has the Android main, iOS target has the iOS main, and so on and so on. Let's say that we have multiple targets like JVM, iOS, ARM64, and JS. Kotlin creates a common main source set for a common code and a corresponding JVM main, iOS, ARM64 main, and JS main sources for these specific targets. During compilation to the JVM, Kotlin selects all source sets labeled with a JVM, like a JVM main and a common main. It then compiles them together to the JVM main class files. Now, when working with a multi-platform project, you need to remember that if you want Kotlin to compile your code to a specific platform, you need to declare a corresponding target. Also, code which is written in a platform-specific source set can access declarations from the common source set. For example, the code in the JVM main can use code from the common main, however, the common main cannot use the code from the JVM main. And lastly, there are intermediate source sets. So an intermediate source set is a Kotlin source set that compiles to some but not all of the targets in the project. For example, let's say that we are building a Kotlin multi-platform project that needs to target all modern Android and Apple devices. And you need a source set to add a function to generate a unique identifier for all Apple devices. Now you can see this function that generates a random unique identifier for Apple devices. So you cannot add this function to the common main because common main is compiled to all declared targets including Android. But this platform.foundation.nsuuid is an Apple-specific API that's not available on Android. So Kotlin would also show a compile time error if you try to access this specific import from the common main. Other solution would be to copy and paste that function separately in each target, like iOS ARM64 main, macOS main, watchOS main, and tvOS main. But that approach would cause a code duplication, and it would make our job a lot harder when it comes to the code maintenance. To solve this issue, you can use an intermediate source set. So an intermediate source set is a Kotlin source set that compiles to some but not all of the targets in the project. Kotlin creates some intermediate source sets by default. In this specific case, the resulting project structure would look like something like this, with the Apple main source set created for that matter specifically. This Apple main source set compiles to only Apple targets. Therefore, Kotlin allows using Apple-specific APIs in the Apple main, and you can add this random UUID function here. Alright, so that's everything I wanted to share with you in this video about the targets and the source sets. And soon you will learn how to use them in practice as well. So if you have any questions, feel free to comment down below. And for this video, that will be all. In a Kotlin Multiplatform, expect and actual declarations are used to define platform-specific implementations. This allows you to write shared code that can be used across multiple different platforms such as JVM, Android, iOS, and more, while providing platform-specific implementations where necessary. This expect actual mechanism is used by many Kotlin multi-platform libraries so that we don't have to write platform-specific APIs on our own. When it comes to expected and actual declarations, there are certain rules that needs to be followed. The first thing, we can use actual and expect mechanism with functions, properties, classes, interfaces, enumerations, and annotations. Then we need to mark them with the expect keyword, and this is your expected declaration. So these declarations can be used in the common code, but shouldn't include any implementations. Instead, the platform-specific code provides this implementation. And the platform-specific code is declared in a platform-specific source set. The only difference is that in a platform-specific source set, we use actual keyword instead of the expect, because here we need to define the actual implementation. Following those rules is important because a compiler will check whether the expected definition is defined inside the corresponding platform-specific source sets. And if it isn't, you will get a compile time error. So while generating the resulting code for different platforms, a Kotlin compiler will merge the expected and the actual declarations that correspond to each other. It will generate one declaration with its actual implementation for each platform. And every use of the expected declaration in the common code will call the correct actual declaration in the resulting platform code. Now let me give you an example. Let's say that we want to write a simple function that will take advantage of a Bluetooth API in both Android and iOS, and return a list of strings where each one of them will represent a device in our surrounding. A Bluetooth API is different in Android and iOS, which is why we need to define that in two different places. In the shared module, we would create a Kotlin file and an expected behavior of that function. That expected definition is important, and it should be the same as the implementation in both platforms in this case. Then, in all our specified targets, we would have to write the implementation or actual declaration of that function definition that we have specified. And now that we have defined that functionality on all of the targets in our project, now we can call that function from both platforms, and each target will trigger the corresponding functionality. That's how Kotlin multi-platform libraries work behind the scenes. In the shared module, we could call that function once and it would be successfully compiled natively to both platforms. As I already mentioned before, you can use this expect actual mechanism on functions, properties, classes, interfaces, enumerations, or annotations. Also, an alternative approach of this mechanism is the use of interfaces. For example, in the shared common main, you could declare an interface and its definition. And then, in other platform-specific source sets, you could implement that interface and define its implementation differently on each platform. With Kotlin interfaces, you don't limit your design to one implementation per target platform. Also, it's much easier to substitute a fake implementation in tests or provide multiple implementations on a single platform. Now, one thing to note is that you cannot use the actual and expect mechanism on a data classes, because data classes do contain an actual implementation like a toString, hashcode, and equals function. But instead, for expect and the actual declarations, you should use a regular class. In that case, you do need to add the actual keyword, not just on the class, but on its properties as well. Bottom line, you should rely on a standard Kotlin language constructs where possible, instead of using expected and the actual declarations. And that's the general rule, which is declared in the official Kotlin documentation. So if you have any questions, feel free to comment down below, and for this video, that will be all. I'm going to talk about choosing the right IDE for our Kotlin Multiplatform project. As you can see, I'm using a Mac OS because in order to run an iOS application, I would need an iOS simulator. And a simulator is available with Xcode IDE, which means you would need to have two IDEs. One for running your iOS application and write your Swift code with Xcode, and the other one, Android Studio, to manage the shared logic, to do the Android part and other things as well. There is also a new IDE which enables you to do everything for a Kotlin multiplatform project inside a single IDE, and that one is called Fleet. It allows you to run both iOS and Android emulator from a single environment without the need to switch between Android Studio and Xcode. However, that doesn't mean that you don't need the Xcode, because you do need it for the iOS simulator in the first place. It's just that Fleet allows you to run it from within itself, so you don't have to switch the environment. It allows you to edit your code in both Swift and Kotlin, supports a code highlighting, code refactoring, usage view for both platforms, and other useful stuff, which in the end results in working with a single IDE. Now, the thing about Fleet is that at the moment of recording this video, it's in a preview stage, which means it's free. But in the future, they will probably remove the free tier and you would have to pay for it. That's why I have decided to go with Android Studio and Xcode this time, so that you can follow this course along without needing to pay for an IDE. Okay, so first you do need to install the Android Studio, and you can do that from JetBrains toolbox. It's a nice little tool that allows you to manage all your JetBrains products quite easily. You can install and update them within the toolbox itself. Quite handy. On my machine, I do have two IDEs right now in this toolbox, Fleet and Android Studio. We are not going to use Fleet in this course, by the way, so be sure to search and install the Android Studio from this tool. Alright, next, after you install the Android Studio, we need to install one more, and that is the Xcode. You can find the Xcode from the App Store, so just search and install that as well. Perfect. In the next video, I'm going to show you how to set up and prepare the environment so that we can start working on our project. Now, before we start working on our Kotlin multiplatform project, we need to set up the environment to make sure that we have all the necessary tools on our system. We have already installed the Android Studio and Xcode, and now let's check whether we have a JDK installed on our system. So open up the terminal and write java/version. Press enter. If you don't get a similar result, then you need to open up your web browser and download at least Java JDK 17. Next, if you are using a Mac OS, then it's a good idea to install Brew on your system as well, if you haven't already. Brew is a package manager that simplifies the installation of a software and command line tools by automating the process of downloading, compiling, and installing. So be sure to visit the official website, download and install this tool. Now, we need to install a KDoctor tool that is available on a macOS only. We're going to use a Brew for that purpose as well. A KDoctor is a software that will diagnose any problem while checking for our environment. It will check whether we have everything we need so that we can start working on our Kotlin Multiplatform project. If you don't have a KDoctor, then use and execute brew install KDoctor command from your terminal. Next, we're going to open up the Android Studio, run the terminal, and input a command KDoctor. Press enter. And then, after that, this tool will start checking our environment. If you see a green checkmark symbol on all those items below, it means that everything is configured correctly. Otherwise, if you see a red cross icon, you will have a detailed response below letting you know how to fix that specific item. Also, if you encounter an issue while fixing one of those items from the list, be sure to Google for a solution because there are already a bunch of different resources on that topic. Great, and now we have successfully configured our environment and we can start working on our project. The first thing, we need to create a Kotlin Multiplatform project. Now, creating a project from scratch may take a while until we add all those targets, source sets, version catalog, etc. Which is why I'm going to use one plugin in Android that will allow us to generate a Kotlin Multiplatform project that targets both Android and iOS, which is quite simpler solution. There is also a new way of generating that Kotlin Multiplatform project. JetBrains has recently announced a KMP wizard, which is available on kmp.jetbrains.com. But in this case, I'm going to use that plugin that I have mentioned at the beginning. So, in Android Studio, open up the settings and click on a plugins section. There, we need to search for a Kotlin Multiplatform mobile plugin and install that. It may require you to restart your IDE as well. After that, click New Project, and from a phone and tablet section, you need to select a Kotlin Multiplatform for a mobile template, which will become available here once you install that plugin. Then, choose a project name and click Next. After that, in this window, you can customize the names of your modules. As you can see, by default, we're going to have one for Android, one for iOS, and a third one for a shared logic as well. I will leave all those information as default and click Finish. You will notice that our Android app module is basically the same as with the regular Android app with Jetpack Compose. There is a slight difference in this template. For example, we don't have the UI package and the separate Kotlin files for typography, colors and shapes. Instead, all those things are now inside one single Kotlin file. Next, if you open up the Gradle build file, you will see that dependencies here are located in the version catalog, which is available in the Gradle directory. Here, in this version catalog, we have all versions, dependencies and plugins that we are using, which is a good thing to have all dependencies centralized in one place so that we can modify them quite easily. Also, you may have noticed that the shared module is automatically added to our Android app module, which means we will be able to access all the logic from that module in our Android application without any problem. I'm just gonna here update the Java version to 17, and if you encounter this compile time error on the top, libraries for libs can't be called in this context by the implicit receiver, then you should just add this suppress annotation, DSL scope violation, since this is a well-known bug in this IDE, which should be fixed in the future. But for now, just leave that annotation right there, and that compile time error will disappear. Alright, that's about the Android app module. Nothing new here, right? Now let's open up the shared module. And here you may see different directories for different source sets. But if you switch to a project view, then you will see only three: Common Main, iOS Main, and Android Main. I suggest you to keep this project view open for the time being. This project template also includes an example. So in this shared module we can see one interface and one expect declaration. Both of them are implemented in the corresponding source sets. In both Android and iOS source sets, you can see that we are declaring those implementations by using a platform-specific APIs. For example, in Android, we have android.ios.build, while in iOS we have iDevice.currentDevice.systemName. And neither one of those APIs could be used in the common main. So we have already talked about that in the previous videos. Also, we have this greetings class in the common main source set, and whenever this greet function is called from an Android and iOS application, each one will print a different text, since they do have different implementations in their respective source sets. Now, the last module here is the iOS application. And even though we can see that module and all its files, we don't have a Swift UI code highlighting available as well as a code autofill, which is why we're going to use the Xcode IDE to code the iOS application. There is also a new Fleet IDE, which will allow you to code both Android and iOS from a single development environment. But since that tool is still in a preview state, I'm not going to showcase it here. So we're going to use Android Studio in a combination with the Xcode. Also, even if you're not familiar with the iOS, Swift UI and the Swift programming language, don't worry, because I will try to explain all my steps of building an iOS application so that you can understand it easily. Plus, Swift is quite similar to Kotlin, their syntax is almost the same, and if you know Kotlin, I'm sure you'll be fine with Swift as well. So when you open up the iOS app module in Xcode, you will see a rather simple user interface. We have a content view file that represents our screen. It implements the view protocol, and in Swift, a protocol may look something like an interface in Kotlin, but it's not exactly the same. In this case, a view protocol represents a part of our application's user interface and provides modifiers that you can use to configure views. Inside, we have an immutable variable or a constant, which is declared by using a let keyword. And the let keyword is something like a val keyword in Kotlin. Then we are calling that same greet function from the common main source set that returns a string value that we want to display on our screen. Below that we have a var keyword, which is the same as a var keyword in Kotlin. It declares a mutable variable. Then this part right here marks the beginning of the computed property body, which is a requirement of the view protocol that we have already implemented. So a body represents the content of the view, and in Swift UI, the body property typically returns a view hierarchy. That's the place where we define the UI of our screen. And finally, inside we have a simple text UI element that displays that greet message. So on the right side of this code editor, we can see a preview window or a canvas that we can easily hide with one click. If you keep seeing this compile time error, no such a module shared, be sure to build your project and then this error will disappear. And finally, let's run our application on both Android and iOS. There you go. Each one of them displays a rather simple message about the operating system. How's that cool? Now, if you keep seeing this compile time error in your project Gradle build file, also be sure to specify that same suppress annotation, but this time be sure to include the file keyword as well. Perfect. We can also check that preview screen back in Xcode without running the application. So enable back that canvas and reload the preview. Amazing! And lastly, let's open up the iOS app file. So this file represents the entry point of our iOS application, and this main annotation is applied for that purpose. Next, we are declaring a new structure that implements the application protocol. And this protocol provides a default implementation of a method that the system will call to launch the application. So you can have only one entry point among all your application's files. After that, we can see that we are also implementing a scene protocol that acts as a container for a view hierarchy that you want to display to the users. A scene is a part of the operating system with a life cycle managed by the system as well. Scenes can be also composed with other scenes, like tabs on macOS, and the scenes form the content of our application. Then, inside the scene, we have a window group. So window group is used to create a view hierarchy for the application, and the hierarchy that you declare for the view's contents serves as a template for each window that the view displays. So SwiftUI takes care of the platform-specific behaviors. For example, on a macOS and iPad OS, users can open more than one window from the group simultaneously. And in macOS, users can gather multiple windows together into a tabbed interface as well. So bottom line, views are the basic building block of a simple iOS application. They do render everything on the screen, and they can be composed with other views, and they form the content of a scene, making them a platform independent. Now, this will not be a full course about Swift and iOS, but you're definitely going to learn some basics while we are building this demo project. So for this video, that will be all. In this video, I will show you all dependencies that we are going to need for this project. But first, let's take a moment to explore a shared Gradle build file. Here, in the Kotlin block, we have an Android target in which we are configuring the JVM target version for all its compilations. I'm going to update that value to 17, by the way. Then, down below, we have a for each loop, and basically we are creating a list of iOS targets for which we want to generate the framework. And the framework, by the way, is used for compiling the Kotlin code from our project into the Objective-C language for the iOS application. That Objective-C compiled code is then used in a Swift code. And that's how we are able to use the Kotlin code in iOS application. As of right now, there is no direct way to compile our Kotlin code to Swift. Instead, we need to do it over Objective-C because of some compatibility issues related to iOS. Anyhow, when you build a project, that Objective-C generated code will be visible in the build directory of your shared module. So open up the headers directory and you will find shared.h file. That file contains the code which is compiled by the Kotlin compiler to Objective-C. If you scroll down below, you will find a greetings class and a platform interface that we have already declared in the common main source set. However, this code is not quite readable and it's hard to figure out what's actually going on right here, especially if you don't know the language. Now, because of this thing right here, it can get tricky if you want to implement some Kotlin feature in Swift, because it may not get compiled correctly, or you would have to create some wrappers in Kotlin, find some workarounds so that the compiler can compile your code correctly, all that so that you can use your shared common API in Swift pretty much the same way as you do in Android. Now, fortunately, there is one amazing open source library that will help us to compile our Kotlin code correctly so that we can have a consistent shared API across both iOS and Android. That library is called a Skie or a Sky by a Touch Lab, and it will help us to call our Kotlin code through Objective-C without having to drop some essential Kotlin features like flow, coroutines, suspending functions, sealed classes, default arguments, and more. So basically, that library will take Kotlin APIs and convert them into the relevant ones that are used in the native iOS with Swift. For example, we use flow in Kotlin, and without this library, we would have to create some wrappers and write some boilerplate code so that we can support that flow in Swift as well. This plugin will convert the Kotlin flow into the async sequence in Swift, which is the similar API as a flow. It's just that a sequence is used natively in iOS. I highly suggest you reading their whole documentation here, especially the features section, so that you can understand and get familiar with the things that they do to help us in order to bridge the gap between Kotlin and Swift. Anyhow, now let's get back to our Gradle build file. So below we also have a source set block that contains all the necessary source sets. Right now, by default, we have two: common main and a common test. I will add two more: Android main and iOS main. Also, I'm just gonna paste here some dependencies and then I'm going to explain. So here in the common main, we have a Kotlin coroutines, we have a Ktor client, Ktor content negotiations, Ktor serialization Kotlin X, and we have a Skie annotations and a Skie Kermit. Now, those last two are the part of the Touch Lab libraries, so Skie annotations is used to manually add some annotations on our Kotlin APIs so that we can tell our compiler how to compile the code into the Objective-C. You can also read more about that in the official documentation on a Touch Lab website. And this last one, Kermit, is a Kotlin Multiplatform library for logging. So we can log some messages on both Android and iOS, which is a great thing. And finally, in the Android and iOS main source sets, we need to add the respective Ktor dependencies for a native HTTP client engines. Also, you can check my repository for more information about dependencies and plugins in the version catalog. And after you add all of those, don't forget to apply plugins in the shared Gradle build file. Then, in the project level Gradle build file as well, and in Android app module, we just need to add a coil image loading library dependency. And that's everything for now. Alright, in this video we are going to create a data transfer object or a simple model class that will be used to model the response that we are going to get from a third-party API. The API that we are going to use to fetch the data and display that in our Android and iOS application is called FakeStore API. You can access this on a fakestoreapi.com website. Click Read Documents button to check a documentation about what data you're going to fetch from it and what kind of a response you're going to get. Select Get All Products category and you will see the actual endpoint that you are going to use. I'm going to use this one down below that contains an additional parameter for limiting the number of retrieved products. We can also create a base URL constant in our project that will hold this value. Great! Now go back and click Show Output button to check what kind of fields that the product data transfer object will have. We could also copy this whole endpoint and paste it into our web browser to see the exact result that we are going to get. Each product has an ID of an integer type, then the title of a string type, price of a double type, description of a string type, category of a string type, and image as well. And we have a rating object that contains one double and one integer value. If you don't want to get all that data, you don't have to. For example, I'm not going to use this rating information in my application, which is why I'm going to leave that information out of my data transfer object. Let's go back to our project and create the new file in the shared common main source set. I will create a data class with the name of a product that will hold all those information that we have just seen. We are going to mark this class with a serializable annotation because we are using a Kotlin X serialization library, which will deserialize that JSON response into a data class in Kotlin. Then, after that, I will add one more additional data class that will hold multiple different product objects, which we are going to pass as a list in our applications. And there you go, we have successfully created a shared data transfer object that will be used by both Android and iOS. In this video, we are going to create one utility class that will allow us to wrap the response from an API so that we can easily react on different states. We are going to create a sealed class that will have 4 child classes: idle, loading, success, and error. Only the last 2 will hold the properties. Success will hold the data that we're going to fetch from an API, while the error will contain the error message if something bad happens. I will also add some additional functions that will allow us to easily check the state of our request state at a runtime. And 2 more additional functions to extract the information from the success and error states as well. This will be quite useful in iOS applications, and you will see about that when the time comes. Anyhow, at the end, just make sure that you have marked all those child classes and objects along with a sealed class with a serializable annotations. And that's it for now. Now it's the time to create the core logic of our shared module. And that will be an API that will fetch the data from the network on both Android and iOS. We are going to use a Ktor client multiplatform library that we have already added as a dependency in our project. So let's create the new products API class. Create a variable that will represent an HTTP client. Call the HTTP client function and let's configure it as well. Inside this block, call install function and specify a content negotiation as a plugin parameter. As a second parameter, we need to configure a JSON and optionally enable certain functionalities within the JSON builder. Perfect. After that, create a new function that will fetch the data from that fake products API. We are going to add one parameter so that we can specify how many product items we want to retrieve. The return type will be a request state wrapped in a Kotlin coroutines flow. Then we need to call a flow builder, and the first value that we want to emit before we fetch the data will be the loading state. Then I'm going to add a fake delay of 2 seconds so that we can actually showcase a loading state in our application later. After that, call try and catch block so that we can catch any potential exception that may occur while trying to fetch the data. And here in the try block, emit a success state if everything goes right. If not, emit the error state, and also we can use TouchLab's Kermit library to log an error as well. Amazing! We have successfully created a shared logic that will fetch the data from the network on both iOS and Android. With this video, we are going to start working on the Android application. The first thing, we need to design the product card composable that will be used to display an information from the product that we fetch from the network. So let's create the product card Kotlin file and a corresponding composable function as well. Add a product as a parameter. Now, the surface of our card will have a rounded corner shape and its background color will be slightly elevated, which is why I'm going to use a material 3 tonal elevation for that purpose. Just call surface color at elevation function and pass number 2 for example. According to the official material 3 documentation, the tonal elevation can go from 0 to 5. Next, inside, we're going to add a column, and the first element will be the async image composable, which is a part of the coil image loading library. I will add a fixed height, specify the image property to be used as a data for this async image, add a crossfade effect, and the content scale to crop. Alright, next let's add a nested column so that we can actually apply some padding on it. The first text will represent the title, it will have a bold font text, the size will be title large, its text will be grabbed from the product object, I will specify the maximum number of lines to be 2, and also we can add an ellipse size as a text overflow if the text is too long. The second one will represent a description of the product, and the maximum lines here will be number 6. Then, below that, I will add a row and place another 2 text elements. The first one for the product category and the second one for the price. And that's it. Optionally, you can also add a preview composable to see how this component will look like. And there you go. In the next video, we are going to focus on implementing the logic for fetching the data and displaying the correct state in our application as well. Alright, so now that we have created the product card, we can start fetching some data. Our application will be quite simple with a single composable screen. Let's create a Kotlin file with the name of a home screen, along with a composable function with that same name. I will also create a view model for that screen. Let's create 2 variables in this view model. The first one, a private variable with a mutable state, and the other one, a public variable with an immutable state. The reason for this is because we don't want to allow variable updates to trigger outside of the view model. That way, we have a better control over our code and we can avoid some unexpected bugs as well. Inside this init block, I will call a viewModel scope and trigger the fetch products function from the products API, from which we want to collect the value and update the variable. I'm using a dispatcher main here because we are updating the variable which will be observed from our UI. As simple as that. Now, in the main screen, we need to initialize the view model and observe that variable. However, you will notice that we cannot access the view model function which is used to initialize a view model in the composable scope, which is why I'm going to add one more additional dependency, compose navigation. We will also receive a warning saying that we could place this dependency in the existing version catalog. So let's do that. Perfect. Now go back, initialize a view model, and create an additional variable to observe the state from the view model. Great. Then, below that, I will add an if check to decide what kind of a UI I want to show to the user, depending on which request state we get as a result. So in this first case, if the state is loading, we want to display a loading indicator. Then, in else if check, if the request state is of a success type, then we want to get that data and pass it to the lazy column composable. And finally, if we get some error, we want to display that error on the center of our screen. There you go. Now, let's run our application to see whether we should be able to receive and display those products correctly. Okay, so after we run our application, we are going to receive here an error. And if we check our logs, you will see that we have received an illegal input, and here you will see a message that will say something like this. Now the reason why is that I have forgot to specify a product's data class as a return type of our success request state. So let me just go back to our products API, and here as a data, I'm going to now call our products class, and then as items, I'm going to pass this HTTP client. So now let's run our application once again. And our data will be loaded successfully. Also, as you can see, if we scroll all the way down, we are going to see that we have fetched in total 10 different products, right? There we go. So with this, we have finally completed our Android application, and from the next video, we are going to start working on our iOS application as well. Alright, so now it's time to start working on the iOS application. First, open up the Xcode and select that same project that we have already created. Mine is called Mobile Demo. I have already talked about the basic structure of this iOS app module. And the first thing, let's create a new file that will represent a product view. Right-click on the iOS app directory, then New File, and from this window, choose Swift file and click Next. Write the name of your file and click Create. Here we have a basic structure of the view. Before we continue, I'm going to add one additional import for our shared module, so that we can actually access the shared logic. Next, we need to declare a parameter that this view will accept, and that will be a product. Now in Swift, the parameter of the view is declared in its body and not inside the brackets, like we have in Android with Jetpack Compose. So let's declare here one immutable variable with a let keyword, and then the expected type. After that, in the body of our view, we need to add something similar to a column in Jetpack Compose. In Swift UI, we have a vStack, which is a short for a vertical stack. I will specify only one parameter for the alignment, so that its child elements can be aligned from the start. Then, inside this vStack, I will add the first element, and that will be the async image, which will asynchronously load the image from the URL. As a URL parameter, I will add a product image as a URL. Then we have a closure parameter, which is used to handle the result of a loading image asynchronously. It provides an image loading result that contains either the loaded image or an error if the loading process fails. In this first block, we are using something that's called an optional binding. That's a Swift concept, which is similar to a safe call in Kotlin. This image property of the image URL can actually be null. And if you check the definition of that property, you will see that it contains the question mark at the end of its type, which indicates that this value can actually be null. In Swift, however, we don't say null, we say nil. But basically that's the same thing, an absent of a value. So here we are creating a temporary variable or a constant that we are going to use if this value turns out to be not null. And in that case, we are displaying an image. Next, in the else if check, we are checking if the image URL has an error. In which case, we just want to display a simple text placeholder to inform the user about it. And in else case, when the image is still loading, we just want to display a simple loading indicator. And that's it. Pretty simple and convenient. Below the image, I will add 2 additional text elements for the title and a description of our product. You can see how the modifier concept in Jetpack Compose is similar to adding different properties on this view in Swift. We can basically access them with a dot. Here, you can see that we have specified the maximum lines for those text elements, then the font size, the truncation mode, which is basically the text overflow ellipse size feature like we have in Jetpack Compose, and other different properties as well. Finally, below those 2 text elements, we need to add a row and place 2 more text elements for the category and the price. For that matter, we can use the H stack or a horizontal stack, which is a similar view to the row composable that we already have in Android. We can also add a spacer between them to add some blank space between those 2 text elements. And there you go, we have successfully created the first product view in Swift. It's quite easy, right? Now, one thing that you could also do here is create a preview. Down below, I will create the new structure that will implement the preview provider protocol. And inside, I'm going to create a product object with some dummy information and pass that same object to the product view as a parameter. Now, let's launch this preview, and there you go. It works like a charm. Perfect. It's time to fetch the data and show it inside the iOS application. First, in the content view file down below, I want to create a new class that will represent something like a view model. Let's call it a home view model. This class should implement an observable object protocol, which is used to represent the data for a Swift UI view. Class that implements this protocol can be observed, and when their properties change, the corresponding views are automatically updated. Next, we're going to create a variable of a nullable request state type, and its default value will be null or nil. It will have a private setter, which means this variable can be modified only within this class and not from the outside. It's readable from the outside and writable only from the inside the class. We have already done something similar in Android as well. The view that depends on this property, which is marked with a published annotation, will be automatically updated when its value changes. Next, down below, we have a function which is used to fetch the data. It's annotated with a main actor annotation, which indicates that this function should be executed on the main thread. This is very important in Swift because it ensures that the UI updates are performed on the main thread, because the UIKit and the Swift UI are not thread safe. The async keyword declares this function as an asynchronous, which will allow us to execute this function without blocking the thread. The await keyword is used to wait for the network result, and when we get it, we are updating the request state property, which will be observed from our application UI. After we have created the view model, now in the content view structure, we are going to define a variable and create an instance of that same view model. We have annotated this variable with a state object annotation, which means that the life cycle of the view model is managed by the Swift UI. It will be created and retained as long as the content view is alive. Next, we are adding a task function on a view body, which is, by the way, an asynchronous function, which means that this block will be triggered when a view appears on the screen. And that's when we want to fetch the data. After that, I will add a vStack and specify a couple of if checks to decide what kind of a UI I want to display based on the request state that we are observing from a view model. In this first if check, if the response is successful, then I'm calling a list view that will allow me to display multiple items in a list. Something similar to a lazy column in a Jetpack Compose. For the data, I'm calling getProducts function to return products items. As a second parameter, I'm passing the ID of each product, and this parameter is something similar to the key parameter of a lazy column as well. Then, inside the body of the list, I'm calling a product view and passing each product. It looks really clean. After that, if we receive an error, I'm displaying a simple text view with an error message to show it to the users. And if the data is loading, we are displaying a simple loading indicator with a loading message. And that's it. Now I think we can try running this application to see the result. First, we see a loading indicator, and then all those products that we have fetched from the network. Now, let's try disabling the Wi-Fi on this Mac OS so that we can test the error case of this application logic. Now, run the application once again, and you should receive an error message because the internet connection is currently not available. For more information, you can always check the logs because we have already implemented the Kotlin Multiplatform logging library. And that's it. We have successfully completed our first Kotlin Multiplatform mobile application for both Android and iOS. So if you have any questions, feel free to comment down below, and for this video, that will be all.